Hello students, so in this video we're going to go over section 1.3, truth tables for negation, conjunction, and disjunction. And in the next section 1.4 we'll finish up the truth tables for the conditional and biconditional, but I did want to break up the truth tables into two sections. So our goal for this first section is to go over the truth tables for the negation, conjunction, and disjunction separately, but then we'll use that information to construct truth tables for other statement forms using combinations of those logical connectives. So a truth table is a device used to determine when a compound statement is true or false. And remember, a compound statement is a statement that contains two or more simple statements, so it conveys two or more ideas. I have a note here that the answer column, or the main column, in our truth table is always going to be the last column that we complete. And that's the column we look at to determine when our compound statement is true or false, under what conditions. So we'll look at the negation first. So if P is a true statement, then the negation of P, not P, is going to be a false statement. And if P is false to begin with, then when we negate P, that becomes a true statement. So in other words, the negation of P, not P, will always have the opposite truth value of P. So the truth table for the negation is really simple. Over here, we have P. And P, since it's a statement, is either going to be true or false, right? That's what a statement is. It's a sentence that's either true or false, not both, not neither. So in the first case, I have that P is true. So when I negate it, it's going to have the opposite truth value. It becomes false. If I have that P here is false to begin with, when I negate it, it'll be true. So if I say this is calculus 1, which it's not, that would be a false statement, and then if I negate that statement and I say this is not calc 1, that becomes a true statement. So the negation is just going to change the truth value. Then we have our conjunction. So the conjunction of P and Q, that's how we'll read it, P and Q, and remember the symbol for the conjunction. This is going to be true only when both P and Q are true. If either P or Q is false, or if both of them are false, then the conjunction ends up being false. Okay, so we have a slightly larger table now, because now we have P and we have Q. So these are our different cases. You're going to have 4 cases now that we're working with 2 simple statements, P and Q. In the previous table, we just had one simple statement, P, so it was either true or false. There's only 2 cases. But once we introduce a second simple statement, Q, we're going to have 4 cases. So you can think of this first one here, this is like case 1, where both P and Q are true. And then in that case, the conjunction here ends up being true. In case 2 and in case 3, either P or the Q are false, right? So in case 2, P is true, Q is false. So for the conjunction, if one of those is false, then this overall compound statement, the conjunction, ends up being false. In case 3, P is false. So the whole thing has to be false. And in the last case here, case 4, both P and Q are false, so the whole thing is false. So the only time when your conjunction is going to be true is going to be in case 1 where both P and Q, both of those simple statements are true. That's the only time when the conjunction is true. Okay, now we have the disjunction of P and Q, which is read P or Q, and remember what that symbol looks like. The disjunction, P or Q, is true when either P is true or Q is true, or both of them are true, and it is false only when both P and Q are false. Remember this disjunction, when we read it as or, it is the inclusive or. So the table for this, we have our four cases again. So case 1, they're both true, both simple statements. Case 2, P is true, Q is false. Case 3, P is false, Q is true. And in the last case, case 4, they're both false. So in case 1, they're both true, so the disjunction is true. In case 2, at least one of them is true, right? P is true, so the disjunction is true. In case 3, one of them is true, Q is the true, right? So then the whole disjunction is true. And then in the last case, they're both false. So that's the only time when your disjunction ends up being false, when both P and Q are false. Order of operations. So just like with arithmetic, you're going to have an order of operations when it comes to the logical connectives. So the first thing we're going to do is evaluate the operations, the logical connectives that are inside parentheses. That's the first thing we're going to do. Then we are going to evaluate the negations. After that, we'll evaluate conjunctions and disjunctions. And in this case, parentheses will indicate which of these to do first, the conjunction or the disjunction. So I think we mentioned this in an earlier video, but if you have something like this, P and Q or R, that's ambiguous because you're not sure if you should do the conjunction first or the disjunction. So you should, if you see something like that, there should be parentheses around either the conjunction or around the disjunction part so you know what to evaluate first. And when we get into equivalent statements in a later section, we'll see that these two statement forms here are going to generate different truth tables. They're not logically equivalent statements. I do have a little note here that a complete list of the order of operations will be given in the next section because we are going to add on how to evaluate or when to evaluate conditionals and biconditionals to this list. I do have a comment here. So to determine the number of cases that a truth table should have, you're going to use this little mini formula, 2 to the nth power, where n is the number of distinct simple statements in the statement form. So if you think back to that very first truth table we did for the negation, we only had P, right? So we had just one simple statement. So we would have 2 to the first, which is 2, and that's how many cases we had. But when we had P and Q, or we did P or Q, you had 2 simple statements. So that would be 2 squared, which gave us 4 cases. So if you have a simple statement that has a P in it, a Q in it, and let's also do R, now you're going to have 2 to the third power because you have 3 simple statements. So this is going to end up giving you a truth table with 8 cases. So you can see how large these get. All right, example 1, we're going to construct truth tables for the following statement forms. So let's go ahead and take a look at part A. So what I'm going to do is, since we have 2 simple statements, P and Q, I'm going to write those down first. I'm going to list out the cases. The first case is going to be when they're both true. Then case 2, I'm going to have P as true, and I'm going to make Q false. In the third case, I'll make P false, Q true. And in the last case, both of these are going to be false. Right? These are all the different possible combinations of true and false. Okay, so then I have P and not Q. All right, so our order of operations tells us to take care of things in parentheses first. I don't have that. And then take care of negations. So negations come before the disjunction that we have. So what I'm going to do is I'm going to negate Q. So I'm looking at these values here, and I'm going to negate those. So not Q, if I start out with a true statement, it's going to become false. If I have that Q is false, negating Q becomes true. I have Q is true here, negate it, it becomes false. And then down here I have that Q is false in that last case. So when I negate the false, it becomes a true statement. And then if you want, I'm not doing anything with P here, so if you want to, you can just copy down the truth values for P. They're not changing, they're true, true, false, true. So true, true, false, false. So I'm just copying those down. So we took care of the negation, and now we're going to do the disjunction. So we're looking at these values here for the P, and we're looking at these values here because we're doing the disjunction between P and not Q. So we're looking at true and then this false. And then from earlier, only one of these has to be true for the disjunction to be true. So that in that first case then, the disjunction is true because I've got true for P and I have false for the not Q. In the second case, I have true for P, true for the not Q. That's going to clearly be true. In the third case, I have a false for P and a false for the not Q. Well, both of those are false, so that disjunction ends up being false. And then in the last case, we have false for P, true for not Q. So at least one of them is true, so the disjunction is true. And then what I do is I like to box in this last column that we complete. That last column there is your answer column or main column for your truth table. So this tells you what the truth values are for this overall compound statement, that statement form under these conditions here, or those cases. So you can think of it this way. This is how you can read it. This compound statement, the statement form, is only false when P is false and Q is true. So that's how you can read it. So the idea here is we're basically building truth tables for more complicated compound statement forms using the three tables that we went over for negation, conjunction, and disjunction. So let's look at part B. So here we've got three simple statements. So we're going to have 8 cases. So we have P, Q, and R. And I'm going to list out the cases first. So in the first case, they're all going to be true. And then in the second case, P and Q can be true, R is going to be false. Third case, P is going to be true, Q is going to be false, R is going to be true. Fourth case, P is going to be true, Q is going to be false, R is going to be false. Fifth case, P is false, both Q and R are true. And that sixth case, P is false, Q is true, R can be false. And then in the seventh case, P is false still, Q is false, R is true. And in the last case, the eighth case, all three simple statements are false. Okay, those are all the possible cases. And then we're going to go ahead and copy down the statement form that we're working with. P and parentheses Q. Oh, I said P and, that's P or. And then in parentheses Q and not R. All right, so we're going to work our way from inside the parentheses out, right? Order of operations tells us work with the stuff inside the parentheses first. And inside the parentheses, we have both a conjunction and a negation. The negation comes before the conjunction. So I'm going to go ahead and negate R. So I'm just going to switch over all of these truth values here. They're just going to get swapped. So instead of true, we're going to have false. Instead of false, we're going to have true. And so on. These are all alternating. Okay, so that's the negation of R, that column there. Then I'm going to go ahead and we're still working inside the parentheses, so I'm going to do the conjunction first. So we're looking at the truth values for Q, And maybe I'll go ahead and I'll write the truth values for Q just underneath Q. So we're looking at this column here and for the Q, and then this column over here for the not R, and we're going to do the conjunction for those. So we have true and false. That's going to be false because our conjunction is only true when both sides of it is true. So true and true ends up being a true statement. In the third line here, third case, we've got false and false. So that's false. In the fourth line, we've got false and true. That's still false. In this fifth line here, we've got true and false, false. In the sixth line, we've got true and true. All right, so our conjunction's true there. In the seventh, we have false and false, so that's got to be false. And in the last line, the last case, we have false and true, so that's going to be false, right? The only time it's true will be here and here when both sides of the conjunction are true. All right, now we're done with the stuff inside the parentheses. We've taken care of this. So now we're going to do the disjunction. All right, so P, I'm just going to copy down its truth values just underneath P. And so now the columns we're looking at are this column here underneath P, and then the last column we filled in over here, which was under the conjunction. That's what we just took care of after the negation. So we're looking at those two columns I've kind of circled in blue to do this disjunction. And the disjunction, just one of the sides have to be true. So in the first case, we've got true or false, that's true. Second case, we've got true or true, that's true. Third case, true or false, that's true. Fourth case, true or false, that's true. Fifth case, false or false, that's false now. Sixth case, false or true, that's true. Seventh case, false or false, that's false. And in the last case, false or false, that is false. And then like before, I like to box in that last column that we completed, just to emphasize that there is your answer column. That is the main column for this statement form. So now that we know what the truth tables are for the negation, conjunction, and disjunction, we can come up with truth tables for a whole variety of statement forms. The exclusive OR. So far the OR we've been working with is the inclusive OR, one or the other or both, right? So it's P or Q or both P and Q. When we use OR in its exclusive form, the statement P or Q means P or Q but not both, or you can think of it as P or Q and not both P and Q, which translates into this symbolic form here. So this, it looks kind of messy, but that is the exclusive OR. That is one or the other, but not both. Sometimes, depending on the textbooks, there might be an abbreviation, a different symbol for the exclusive OR. So you may come across this notation here or this other one, and those represent the exclusive OR. So you may see those when you're studying symbolic logic or discrete mathematics. So let's go ahead in example 2 and construct the truth table for that exclusive OR. So it looks like there's a lot going on, but at least it's just the two simple statements. So we're only going to have the 4 cases. Okay, there's all the combinations of true and false. And I'm just going to copy down that symbolic form for the exclusive OR. And then using our order of operations, we've got a couple sets of parentheses that we're going to have to work on first. All right, so I'm going to take care of this part here, this set of parentheses. So we've got the disjunction between P and Q here. So that's just going to be, look at these, right? So it's going to be true or true is true. True or false, true. False or true, true. False or false, that's false. All right, so that is the truth, those are the truth values for the disjunction. Now we're going to go over here to the other set of parentheses, and we're going to work on the conjunction. So we know that the conjunction is true only when both P and Q are true, which is going to be that first case. And then every other case, the conjunction's false. All right, so we have both sets of parentheses taken care of. We've got the disjunction and that conjunction inside the parentheses. Then you have another conjunction, but also a negation. So your negation comes before this outside conjunction. So what we're negating here is everything after it, which is you're negating the conjunction of P and Q. So we're going to switch over all of these truth values. So true becomes false, false becomes true. Okay, just going to box this in a little bit. All right, so that's the last column we've completed now, the negation. So now we're going to go, and so we've negated this part. So now we're going to go ahead and do this conjunction. We haven't taken care of that yet. And for that conjunction, the columns we're looking at will be this column here, P or Q, and this column here under the negation. That second to last column we're doing is the one under the negation. All right, so now we're doing the conjunction. So we're looking at true and false. Well, that's false because it's the conjunction. Then we have true and true. Okay, that's true. True and true. That's true. And then we have false and true, and that is false. Okay, that was the very last column we filled in, so I'm going to box it in because that's the answer column. That's the column that represents the truth values for this exclusive OR statement. So the exclusive OR is only true when P is true or Q is true, but not when both of them, right? Not when both of them are true. So your exclusive OR is like when you go to a restaurant and they'll say your dinner comes with a soup or salad. So it's the exclusive OR. It's soup or salad, generally not both. Example 3. How many distinct cases are needed to construct a truth table for the following statement form? We're not actually going to construct the table, but if we were going to, how many cases would we need? So our formula tells us you're going to have the number 2, and then the exponent on number 2 is going to be the number of distinct simple cases in the statement form. So you're just going to count up the distinct simple statements in your form. You've got P, you've got R, S, and Q. So you have 4 distinct simple statements. So 4 is going to be the exponent on the 2. So 2 to the 4th power is going to be 16. So you would have to have a table with 16 cases just for this statement form here. And there's a couple things I want to emphasize. I'm saying 4 distinct simple statements. So let's say you have this statement form, but then maybe also you have another disjunction and another P. Well, if you have the P here and the P here, you're not going to count that twice because it's got to be the number of distinct simple statements. So if you have P twice, you're just going to list P as one particular simple statement, and it's not going to impact the number of cases. And the other thing I want to mention, I forgot to mention this earlier, but the reason we have 2 to an exponent, that 2 represents the truth values that a simple statement can take on, right? A simple statement is either true or false. It can only be one of 2 things. So that's where the 2 comes from, because it's either true or false, each simple statement. 2 things that it could be. Example 4. Write the statement in symbolic form and construct a truth table. And then answer this question. Under which conditions is the compound statement true? So we have it is false that Ross is a professor or that Monica is a chef. Ross is a professor or Monica is a chef. So since the it is false comes in the beginning, we're going to end up negating everything after it. It is false that, so we're negating everything after it. We have Ross is a professor. That is a simple statement there, so that can be P. So P is going to be Ross is a professor. And then the other simple statement is Monica is a chef. That can be Q. And you do want to identify what your statement variables are representing. So we have Ross is a professor, P, or, that's our disjunction, Monica's a chef, Q. So that's the statement form we have. So now we're going to come up with a truth table for it. So we have two simple statements. So we're going to have our 4 cases. And we do have parentheses, so we're going to take care of the stuff in the parentheses first. The disjunction is going to be true as long as P or Q or both of them is true, and the disjunction is only false when both P and Q are false. So that's for the disjunction, and then the negation is outside of that set of parentheses, so that we're going to negate all of these values. So we're going to have false, 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 true. And then, like I did before, we're going to box that in. That's our answer column or main column. So this question here, under which conditions is this compound statement true? So that only happens at the end there. That's the only place where you have a true statement. And that's in case 4 when both P and Q are false. I'm going to write that out. So statement is true when both P and Q are false. Those are the conditions that are going to make that overall compound statement true. Determining a truth value without a table. All right, so we're going to go over one more example in this section, and this last example, it goes over an alternative method for determining a statement form's truth value when we're given specific truth values for all of the simple statements that make up that compound statement. So for example 5, we want to determine the truth value of this statement form if P is false, Q is true, R is false, and S is true. So here we saw this earlier. This here has 4 simple statements. This would have 16 cases if we were to go and do the whole truth table for it. But we only are interested in figuring out what's the truth value for this statement form under these conditions. So these conditions that are listed here is one of the 16 cases. So if I don't need the other 15 cases, then I'm going to do an alternative method. So what I'll do is, I'm just going to copy down the statement form first. And then what I'm going to do is I'm going to replace all of these simple statements with their corresponding truth values. So I have negation, and then in parentheses I have P or R. Well, P I'm told is false, so I'm actually going to replace the P with an F, with its truth value. Or R I'm told is also false, so I'm going to replace R with F. Then we have and then we have S. S I'm told is true, so I'll replace S with a T. And Q is also true. So I'll replace Q with the T. So replace all the simple statements with their truth values. And then I still am using order of operations, so I'm still going to work from the inside out. So I'm going to do this set of parentheses first. I have to take care of both sets of parentheses. I'm going to do this one first, though. If I have false or false, that's going to be false. I still have this negation here, so I'm going to bring that down. I still have this conjunction, so I'm going to bring that down. And then inside the second set of parentheses, I have true and true. Well, that's true. So that gets replaced with a T. Then we have a negation, which is going to come before the conjunction. So I'm negating just this F here, because I don't have any parentheses to override the operations. So the negation of a false statement, is a true statement. That should be T. And we still have this T. So now we're down to our last logical connective, this last operation, this conjunction. And we have true and true. So that is going to be a true statement. So this is how you would do it. This is the alternative method. So for this particular statement form, under these conditions, these truth values for all of these simple statements, that statement form ends up being true. And this is how you would work it, just like vertically down your page. You don't use any equal signs or anything. And then usually you do circle in the very last truth value you find. All right, that's it for this section. Make sure you do the homework for 1.3. And in the next video, 1.4, we're going to go over the truth tables for the conditional and biconditional logical connectives.